So let's go to that line 67. And I'm having a bit of trouble because this screen is a lot smaller than I'm used to. Okay, so we're here, line 67. Let's see what the local arguments, what the variables are. Process 0, using that line 1 to 4. Okay, so in the current line, so these are the variables I have in the current line, and buffer 0 is some ridiculous integer number. Rank underscore left is -1, and this is going to be a problem because that means that rank number 0 is trying to send information to an MPI task which doesn't exist, which is task number -1. What this is telling me is that somewhere in the code, when I was setting up rank left and rank right, I probably didn't make any special consideration for the two ranks at the very edges of the array, which are 0 and 15. And if I go to 15, 15 receive rank left, no, but I need rank right. Exactly. So if I'm in processor 16, my rank right, this is the process I expect to be on my right, is 16. Now the problem is that MPI numbers from 0 to 15, so process 16 does not exist either. What I'm going to do is I'm going to look in the source code window here what I did to set up my rank left and rank right. And you can see immediately that I didn't take care of any special cases. I have rank left equals my current rank -1, and rank right equals my current rank +1. So what I need to do now is I need to specify in the code that special condition for those two processes. And that's what I'm going to do very quickly. I'm going to get out of here. I'm going to open that. Actually, I have it done already, so I'm going to open the code when it's done, and I'm just going to run it. $64.10. And it turns out that the license server for DDT just went down. Oh, that's convenient. Okay, give me a second, see if I can get another one done. Is Tommy please? Is Tommy here?
No, I just came past his office.
Okay, so let me wait 5 seconds, see if the server becomes available again. I find it strange that we will run out of licenses because we have 4,096. So that's probably the server resetting itself. In the meantime, I'm going to edit that code. So that was so MPI bug. And on the initialization stage for the ranks, add 2 conditional statements. If my rank is 0, set rank left to non-prox -1, and if my rank equals non-prox -1, set rank right to 0. And what this is doing is creating a periodic array in one dimension, which is the same problem that we were trying to solve with the sequential case. So I'm going to compile this again with debugging flags and optimization. I'm going to call it MPI bug version 2. And I'm going to hope that our problems with the license server are gone. Bug version 2. Nope. And this would be a problem because it's the same license server for all the systems. Well, so if the license server doesn't come up, I'm going to have to cut this short. But what I can do is I can tell you the different steps that I followed in the MPI code to sort it out, so that if you want to try this later on, at least you know more or less where to look for the problems. Pretty annoying, but there's not much I can do right now. Okay. Oh, okay, here we go. Thank you. Okay, so we just got the license server restarted, and I just lost my welcome window. Okay, so run on debug. Hey. So what I'm going to run on debug now, with exactly the same parameters as before, so I'm just going to hit submit so that it gets queued up, is the corrected code where I have made sure that all the MPI communication goes to the correct ranks. So now we no longer have these messages being trying to be sent to processes -1 and 16, which didn't exist, and we should be able to at least go past that first communication stage. That's unless there are additional problems with the MPI ISend and MPI receive calls that we have. Because if you notice on the source code, this source code uses 2 MPI immediate sends and 2 MPI blocking receives, which means that if we made any kind of errors in the arguments of the MPI receives, we could easily get into a deadlock situation where the tasks that are trying to receive never complete the interchange of messages, in which case we will have a deadlock. And the way you would see that in DDT is because you no longer see any output, you no longer see your tasks flashing between green and pink, and after a while you just think, okay, I expected to have output 3 minutes ago, nothing has happened. You should pause the execution and have a look at what's going on. And that's exactly what I'm going to do now. I am not even going to set a breakpoint. I am just going to start running the code straight away and see what happens. So the code is running. You can see in the standard output that process 0 has already printed to screen that the size of the array is 64 and the number of iterations is 10, but nothing else has happened. And this should be really fast. I mean, in a couple of seconds, even less, I should have had a solution, which probably means that I have some problem in my communication. Also, you will see all your tasks are in green. They're not switching. Everything seems to have stopped. So I'm going to hit the pause button up there in the top left. Let me reduce this area a little bit so that we have a better view of the source code. And I'm going to have a look at where everybody has stopped. So DDT by default is telling me that at least task number 0 is stopped here in this line 70. I'm going to look at the parallel stack to see what's going on. And I see that there are 16 processes from 0 to 15 stopped at the same line, line 70. And this is an MPI receive. So to me, this already looks like a deadlock. There is some mistake in this MPI receive that is making me not being able to complete the messages. But let me have a look at the message queue. So I go to